Last time we discussed the various ways we could expand binomial expressions. Today we are going to be solving one or two problems, and we titled this class as Tutorials in Binomial Expansion. The question we are given here says obtain the first three terms of the binomial expansion. This is the term to be expanded binomially. And then we're told that its first three terms, that's the emphasis, using binomial theory. So if you're going to solve this, all right, our solution, recall that we said the binomial theory, the statement is x plus y raised to power n is equal to n combination 0, and then you have x raised to power n minus 0, then you have y raised to power 0. And then the next term will be n combination 1, x raised to power n minus 1, then you have y raised to power 1. So the expansion continues until you get to the last term, which is going to be n combination n, then you have x raised to power n minus n, then y raised to power n. This is the statement of binomial theory. So if you bring the binomial expression to be expanded, you write it this way. You have 1 over 2x, everything raised to power 4, and then by simple deduction or reasoning, 3 stands for x, and then minus half x stands for y, and then n stands for 4 stands for n as powers. So if you're going to carry on the expansion, you're going to have 4 combination 0, then you have 3 raised to power 4 minus 0 in that order. All right, 4 minus 0 is 4, so let it raised to power 4, and then we have minus 1 over 2x raised to power 0, then we have plus 4 combination 1, and then we have x raised to power 4 minus 1, that's going to be 3, then we have minus 1 over 2x raised to power 1. The third term, this is the first term, and then this is the second term. So our third term will be 4 combination 2, and then we have sorry, this is going to be 3. So sorry about that. So we're going to have 3 raised to power 3 raised to power 2, and then we have minus 1 over 2 x, everything raised to power 2, right? So this expression, we will have to sort it out by some level, using some level of concentration so that we can avoid. So of course I told us last time that if we have n combination 0 is the same thing as 1. Therefore we can say that 4 combination 0 is 1. And then also if you have minus half, everything raised to power 0 is equal to 1 using indices. So from the first term, what we are left with, we have 1 times 3 raised to power 4 times 1, everything plus. So if you find 4 combination 1, the result is going to give you 4, and then you have, it will be 4 times 3, and then there's going to be minus because of this minus half x in the bracket. So you're going to have x because of this half, there's going to be 2 down there. All right, so this sign changes to minus, and then the next one we are going to have 4 combination 2, that's going to give you 4 times 3 times 2 times 1 divided by 4, of course, times 1 over 4x. All right, so if if you continue the evaluation, you're going to have, this is going to be 81 minus, this is 27 times 2. That's going to be 54x. Then we have this 4 is going to cancel this. 2 here is 1, 2 here, that's going to be 2. Of course, this x is squared, right? So what we're going to see here is going to be 3 over 2x squared. Alright, of course, the expansion continues, except that we are meant to stop at the first 3 terms. So the result is going to be 81 minus 54x plus 3 over 2x squared. That is the result for 3 terms. So another case is this before us. Here, instead of using figures, they are using alphabets, but it's still the same approach. The instruction says the first 4 terms of this expression if expanded, and then we are to use binomial theorem. So by now we are used to the expression, the general expression for binomial theorem, and what it says that if you have your x plus y, everything raised to power n, all right, of course we this is the solution. The expansion will take the form like this. We have x raised to power n, y raised to power 0, plus n combination 0, x raised to power n, the power reduces by 1. The trend is as the powers of x are decreasing, as the terms increases, the powers of y are increasing starting from 0. So the next one, sorry, it's going to be combination 1, then y raised to power 1. And then you have n combination 2, then you have x raised to power n minus 2, y raised to power 2. So it continues like that until the last term becomes n combination n, x raised to power n minus n, then you have y raised to power n. Now, noting that we are interested in the first 4 terms, so in our substitution, bring down the given expression, you have p plus qx, everything raised to power a. I'm sure somebody will be wondering what concerns p, q, and a. Of course, you have to keep to the rules of the game, right? So if we want to expand this, what it means is that our p will come for x, our q will come for y, of course qx is going to go for y, everything here, qx goes for y, and then our n goes for a. So the first thing we're going to write is a combination this, then we have p raised to power a, then we have you have qx, everything raised to power 0, then we have a combination 1, then you have a raised to power minus 1, we have y, our y is going to be p, then we have qx raised to power 1. The next term is going to be a combination 2, and then our next we have, this is going to be, here, this is going to be p raised to power a minus 1. And then the next one is going to be p, then you have a raised to power p raised to power a minus 2, then we have qx, everything raised to power 2. All right, so the 4th term would be a combination 3, then we have p raised to power a minus 3, we have qx raised to power 3. That would be our 4th term. So simplifying, we're going to have a factorial over a factorial. Of course, A combination 0 is going to be 1, so we don't need to bother ourselves so much about that. So, and this one is going to be p raised to power a times 1. Then the next one is going to be a factorial over a minus 1 factorial. And then what we have here will be p raised to power a minus 1. Then we have qx. The next term will be a factorial over a minus 2 factorial. And then our next term will be p raised to power this. Then we have q squared x squared. Finally, the last term becomes our a factorial over a minus 3 factorial. Then we have 3 factorial. So of course this has to it will be this factorial, then 2 factorial. All right, so this is the fourth term. We're going to have p raised to power a minus 3, then we have q raised to power 3, we have x raised to power q. So finally, the last, the expression standing, we have our p raised to power a all plus, we have a, all right, a factorial means we have a times a minus 1 factorial. It continues like that, and then you have a minus 1, then you have it as factorial. All right, so the further simplification of that will be p raised to power a minus 1 qx. Then you have this one as a, it's going to be a times a minus 1 into a minus 2 factorial, and then you have a minus 2 factorial, we have 2 factorial, and then the next term that follows will be you have p a raised to power minus 2, then you have q squared x squared all plus. The last term we're going to have, the fourth term would be a, you have a into a minus 1 to a minus 2 to a minus 3 factorial. All right, that is deliberately done to take care of what is in the denominator. You have a minus 3 factorial, you have 3 factorial, and then we have p raised to power a minus 3 q raised to power this, we have x cubed. So some of the terms we cancel out. This is going to cancel this, and then this will cancel this, then this is going to take care of this. So if I'm going to write the standing this, we're going to have p raised to power a plus, what remains from here we compute, we're going to have a, then we have p raised to power a minus 1 qx. Then the next standing we're going to have here is a, so we have a into a minus 1, all right, then we have p raised to power a minus 2, we have q squared x squared divided by what is down there is 2 factorials means 2, and then the last term, which is the fourth one they asked us, we have a into a minus 1, then we have a into 2, close the bracket, you have p raised to power a minus 3 q raised to power 3, we have x cubed, and then everything divided by 3 factorials is 6, and that produces the last result for that. Thank you.